So let's talk about thermodynamics. And thermodynamics really is just glorified accounting. And I'm not saying that lightly. It really is just glorified accounting. The world is full of energy. And all thermodynamics tries to do is account for what form that energy is and how much we're changing as we change the behavior of a system. So if you think about how much you're worth financially, you've got a savings account, you've got a checking account. Those count towards your personal worth, but they're not really the exact same type of money. A checking account has checks associated with it, has debit cards associated with it, whereas a savings account is less mobile. Now they're both contributing towards you having money, but they're different forms of money. And if you look at your debts, your credit card debts, your student loans, your car payments, these are all things that count against you, but there are a different kind of counting against you. Thermodynamics is very similar to this. We have what's called the total energy of the system, or the free energy of the system. This is either going to be the Gibbs or the Helmholtz, G or F. And at the general chemistry level, we focus on two forms of energy that can contribute to the total energy. The first is going to be enthalpy, and enthalpy represents the sensible heat components of a system. So these are things we see in terms of temperature changes of the reaction. The second component is called entropy. And what entropy looks at is basically the degrees of freedom, or really kind of crudely, the disorder of a system. And it's going to tell us basically the types of energy that are associated with non-thermal components of the free energy. Now with thermodynamics, don't honestly concern ourselves with the absolute values of this. So we're not worried about how much Gibbs energy we have, or how much enthalpy we have, or how much entropy we have. What we're really more concerned with is the change, because the change is going to tell us whether or not a reaction is favorable, whether or not as we go from reactants to products we gain or lose heat, whether or not the entropy goes up or goes down. So what we see a lot of in thermodynamics is the delta, delta G, delta H, delta S. And the delta is always defined as what we finish with minus what we started with. Now, if we finish with more energy than we started with, we would say this reaction isn't favorable. If we finish with less energy than we started with, we'd say it was favorable. There's a lot of conditions, and those are going to be covered in later videos. Big thing to keep in mind here, though, is that what we are trying to do when we look at thermodynamics is account for all the different forms of energy. In this case, enthalpy and entropy. And these are going to give us an idea of what our total energy is, which is either going to be our Gibbs or our Helmholtz.